Hello everyone, I'm Vincent Dampuri, Product Manager for the Explicit Solver Interfaces and Vehicle Safety Solution in HyperWorks. So today I will present you the updates on the new version 2022.1 release. And as part of the agenda, there are the few points that I will expose you today. So the enhancements we have made in three different Explicit Solver interfaces, Radius, LSDyna, and PAM Crash, and as well as the new tools and enhancements for the vehicle crash and safety solutions. I can give you a quick highlight on the different topics. So the first very interesting topics about the vehicle crash and safety solutions. So you see here an overview on what we have worked on. So the new FMVSS01U and ECR21 solution, the new tool for pre and post processing, the new roof crash, load case setup, enhancement, very important enhancements in the seatbelt tool, and enhancement in the MPDP tool post-processing. And for the explicit solver interfaces, we have new entities introduced, constraint entity, material behaviors, generic enhancements that I will go through, and some enhancement in the post-processing for LSDyna Radius mainly. So let me go through the details of the most important points. First, starting with the explicit solver interfaces, new features and updates. Let's start with the LSDyna interface. So as part of the generic solver profile updates, those are the few points that I have listed here, which are to retain for this new release. So the first one is the new solver profile for LSDyna version R13, which is now available. We have also introduced the capability to import compressed input deck in GZ format. So basically, you can now directly read and import this type of files in HyperWorks, and it will be read totally like a standard input deck. Just understand that this is just for the import, not for the export. We don't export in compressed format. Important point to highlight is in HyperWorks, you will see a couple of panels which have been removed. For all the panels which have an equivalent tool or a workflow or capabilities through graphical interactions or browser capabilities. So those type of panels have been now removed, and this is a first start of cleaning the panels from HyperWorks. You will see more coming in 2022.2 release. Going further, in terms of cleaning up a little bit the profiles and to make it a little bit more simple for the user, we have removed. I mean, we don't expose anymore the profiles R6.1 and R7.1, which are now pretty much useless in terms of usage at the customer level. So we remove those from the list, and we have made some important keyword enhancement, like we do usually for all the different releases, with new keywords and updated keywords. I will not go through the different list. I'm just mentioning here to refer to the release notes to have a detail on those keywords. One of the important changes made is for the meshing. We provide now for the calculation of the minimum size of the 2D elements, the three different methods that LSDyna supports. So which is driven by the value ISTO, so 0, 1, and 2. You see the different calculation methods. So which is very important because based on this, on the method you use for your simulation, this has a direct impact on the elemental time step and of course on the simulation results at the end. So from the beginning, you can set up the correct calculation method when you start meshing, and in that case, have also the correct behavior at the end for the simulation. The new constraint entity is introduced in the Dyna profile. For now, it is used for the introduction of the new solver keyword constraint interpolation spotwell, which was not supported before, which is now supported in this release. Just to notice, this is a new entity, and this entity will be used in a future release to remap now correctly the different constraint keywords in LS-Dyna. So we have those keywords, many keywords, which are called constraint, which are mapped a little bit in multiple entities in HyperWorks, and in order to clean up and make it more streamlined, we will in the future continue to migrate those different keywords to the new constraint entity. A very important usability improvement also with this new introduction of the material behaviors entity is made for the remapping of all the mat add keyword in the LS-Dyna, which are used for definition of add-on features on the different materials like damage, temperature, leakage. And the very important part of this implementation is not just the new entity, which is now available, but also the fact that we have made the selection and the visualization of this entity directly in the material cards. So now you can, from the material entity editor, have access to the mat add cards, which gives you then at this level the ability to visualize the complete material definition. You don't need to switch to another entity to look at, what is the mat add attached to this material. You have everything visualized in one place inside the material entity editor. And just to recall that these keywords were previously mapped into the property, which was not the correct place for having those keywords, and which was also for many users a little bit not easy to find, I would say. An interesting improvement also, which is a generic improvement for all the interfaces in HyperWorks. So I'm just here highlighting this for the Dyna interface. You will see this also for the other interfaces, also in the implicit interfaces. There is now a new workflow created for the coordinate system creation, which is very nice and very user-friendly. So you can, with this workflow, create any type of coordinate system for each solver interfaces here. So here for Dyna, you see, for example, different keyword types that you can use to generate the different type of systems. And here, just for the sake of the demo, you can see this recording. So you can select the location, the type of the keyword you want to generate for this coordinate system, and orient is, as you can see, very nicely done with the user interaction and the move tool. So this is how it works for LS-Dyna, and same will be for all the other interfaces. In terms of post-processing, we made also important improvement with the support of NVH and frequency output files, like the D3, PSD, RMS, FTG, and SSD for the plotting in HyperView. And in Hypergraph, the support of the FRF amplitude and angle files in order to plot those values in Hypergraph. So you have now the complete support for the NVH and frequency solution in HyperWorks. If you recall the 2022.0 release, we supported at that time the new frequency entity in the LS-Dyna profile to perform the model setups. Now you have the post-processing supported, so the complete solution is now available in HyperWorks. And in addition of new support of the strain, energy, density plotting in HyperView has been added as well, which was requested by a couple of customers, which is now available. And just for the sake of your information, those are, let's say, the couple of important issues that we have fixed in this release. I will not go through all of these points, but just mention maybe the first one, which is, in my opinion, maybe the most important one, where we have now corrected the calculation of the position when you have transformation applied on multiple include transforms, nested include transforms. So, for example, when you have maybe 2 or 3 input transforms included in each other. So this is now correctly calculated and supported. Moving now to the radius interface. Here as well, there are a couple of generic solver profiles updates. So like in LS-DYNA, we introduced here as well the import of the compressed input decks, also in the GZ format. Here as well, only for the import process, not for export. The keyword unmesh set, which also was previously mapped into the property entity, is now migrated to the set entity, which is more natural to have this keyword in the set entity and not in the property one. So here you see it's continuously improving and cleaning up the different keywords mapping, which were in the past not correctly done. Same comment as in the LS-DYNA interface with the panels removal for the one which have equivalent tool and workflows in HyperWorks. And for the sake of cleaning up the profiles, which are also more or less useless now, for this solver, we have removed from the list of the profiles all the radius version below 2017 version. And in terms of keyword support and updates, you see the numbers, and for the list and details, please refer to the release notes. Similarly to the DYNA interface, we have also here in the radius profile introduced the constraint entity, which is here used for the mapping of the new keyword merge air body, which is a very interesting new functionality in the radius solver, which give a very similar feature compared to the LS-DYNA constraint rigid body and constraint extra nodes. So for those who know DYNA, you know that these keywords are very useful for the model assembly. So you can, as you can see on the picture, you can have on 2 different subsystems rigid bodies, and just using this keyword, this solver functionality, you can just link and merge. That's the reason of the name. So merge those 2 rigids just by, which is done by the solver automatically. So here as well, just for the sake of the demo here, a quick recording which shows you how to define this keyword, which is very simple. So creation of the constraint entity, selecting the main rigid and selecting the secondary rigid body. And at this moment, you have the link, which is automatically done. So the solver will consider the 2 rigids linked together. So you can link a rigid with another rigid, but you can also, as the constraint extra nodes, you can link a rigid with nodes of another part. So switching to node group, creating the set of node, selecting the nodes, and you are done with your setup. So you see here the main rigid and the secondary nodes which are linked together. Oh, sorry for the title. It's a copy-paste issue. So we are still in the radius profile, and here as well you see the new coordinate system workflow available also in the radius profile. I don't have a recording for this one. This is same workflow as exposed previously in the DYNA one, just the list of the keywords for the selection of the type of coordinate system is of course related to the radius solver. And about the important issues that have been fixed in this release, this is a short list of the most important one, and I would just mention the first one, which have been taken care during the implementation of the coordinate system workflow. So we have a fix at the same time, the visualization and of the skew move to, and the displays of the skew and frame with the new tier attribute values. For the rest, those are standard issues reported by customers which have been fixed in this release. For the PAM crash interface, here as well, a couple of generic solver profile updates. So main improvements here in this release for the PAM-Crash solver profile is the extension of the ID parameterization for a lot of new keywords, which was not supported before. So now it's we have a full-fledged of ID parameterization support in PAM-Crash. In terms of keyword remapping, we have also migrated the C data keywords, which is used for user comments in the deck, which was previously also part of the property entity and now migrated to the comment entity that you can also find in Dyna profile, for example. Here as well, same comment on the panels, which some of them have been removed based on the equivalent tools and workflows existing in HyperWorks. And keyword support updates here as well, please refer to the release notes. And the workflow for the system, as I said, common development for all the interfaces. And here you see the solver related coordinate system keyword that you can access for the PAM-Crash profile. So these are the main updates for the explicit solver interfaces. And let me now switch to the vehicle safety solutions, for which we have made a very nice new implementation and improvements. So let's start with the first new tool. So this is the new tool for the IP impact solution. So for the regulation, crash regulations, FMVSS 201 and HCER 21. We have the full solution available, which means the development has been made not for the pre-processing, so for the model setup, and for the post-processing of the simulation results. So in terms of post-processing capabilities, the tool allows the user to automatically calculate the testing area, to mark the testing area with impact locations, impact points, for which you have different methods available to be created. You can, for example, import test lab impact locations from CSV data, so which is a usual process. Many customer places where the test lab provides the tested location through Excel files, and with the tool you can now directly read this file and get the impact location automatically created on your on the IP model. And in the pre-processing tool, you also have the automatic position of the head form impactor and the automatic export of ready-to-run solver decks for all the impact locations that you want to simulate. And at the end, you have the post-processing, which, as you will see, allow to automatically post-process all the selected simulation and impact locations, and to generate at the end a report automatically from your analysis. So here, recording on the pre-processing side, so you have, as you can see, a new workflow. So previously, the old tool has been completely removed and replaced with this new one, for which we have this new guide bar and workflow available. So as you can see, first you enter the SRP points, or the seat reference points, and go through the selection of the parts for instrumental panel, steering wheel, and windshield. The instrumental panel components are the mandatory one. The others are for the marking. And as you can see now, in a few seconds, you have the impact points created on the IP. So we use for that the design points entity, which are the same entity used for the pedestrian tool. And as you can see, you have also the visualization of all the different marking surfaces which have been generated by the tools, which allows the user for checking and debugging the marking. And once you have the marking finalized, you can switch to the positioning workflow, where you select your head form impactor, the pivot points and the coordinate system of the head. And then by selecting the points that you want to test or to visualize the position of the impactor here, just selecting one point, but you can of course select all of them. And you can see then the tool calculates the position of the impactor. And once this is done, you can export all the simulation decks for the different selected points to be simulated then. And here we switch now to the post-processing in HyperView. So here you see the new tool, which is from the design similar to the pedestrian tool that we have already. And here as well, just by selecting the CSV file, the IP model, everything is automated. Here you see the list of simulation folder which are available. And for each of those, you can select all the folders or just the few one you want to post-process and get this summary plotting on which you have the 3 millisecond clip value on the node on the IP at the impact location. And if you desire, you can also have more detailed post-processing for given points or a selection of impact location. Here, just selecting one to show you the detailed reports or the detailed page for one point. So you have here at this moment, you see the cross sections, animation, and the two graphs for the acceleration and the displacement. And finally, at the end of the process, you can export a PowerPoint report finalized, completely finalized within HyperWorks using the report core functionalities. As you can see, this is just a screenshot of the generated report for this example. So you can have the overall injury summary tables and the different pages showing the injury mapping and different detailed pages for each selected impact location. So this is a complete solution and which replaced the previous and old solution we had in the past, which was not fully functional. Now this one is very much functional and competitive with other solutions on the market. And if you have any question on this one later, please don't hesitate to contact me directly. In terms of improvements as well, and the new load case supported in the safety vehicle safety tools, the roof crush load case is now added in the barrier positioner. So if you remember, we had the barrier positioner a few releases ago, and this workflow allows you to automatically position the barrier or the impactor around the vehicle for the different load cases, front, side, and rear. And now we have added the roof crush regulation. So which this tool will automatically position the plate above the vehicle as per the regulation and define, of course, automatically the solver transformations, which are then used for the positioning of the impactor plate. So here as well, a short recording showing you the process. So you enter the barrier positioner, select the roof crush load case, which side of the vehicle you want to impact. Select the barrier component, which must be in an include file, just to recall this specific point. Select the roof component, and then the positioning happens automatically. As a comment on this process, again, or just to recall, we are within this process only positioning the impactor. We are not generating any loads or boundary conditions. So we are not setting up the complete load case within this process, but we consider that the plate, for example, can already have the imposed displacement or the displacement load already defined. So pretty much once you have positioned the plate, the load case more or less already set up. Moving forward with the important enhancement in the seatbelt tool. So here we have enhanced the wrapping quality of the belt around the dummy and the seat by adding a new component selector, a wraparound component selector inside each seatbelt segment. Why we did that? Because previously we only had one selection of wraparound component, which was on the seatbelt system level, and which was applied for all the seatbelt segment. And using this approach, we ended sometimes in some configuration with a bad wrapping. For example, having the thorax belt wrapped around the seat cushion, for example. So now you can, with this new selection of wraparound component inside the seat belt segment, have a better control on each segment around which component they need to be wrapped. So they will not, so like that, you will not have interferences for the wrapping with other components which are maybe defined in different seatbelt segments. So this is an important enhancement because sometimes the bad wrapping, the wrapping couldn't be done correctly because of this limitation. And another one, which is also I would say usual workflow for many users. Let's say you have a seatbelt system already created and you have a new seat and dummy configuration, or a new seat or a new dummy type, and you just want to import or readapt your existing seatbelt system to the new seat and dummy configuration. This process was not really possible in the previous releases because redefining the seatbelt path wasn't updated the complete seatbelt system and all the entities attached to it. So the user needed at that time to redo the seatbelt pretty much from scratch manually. Now it's now completely automated. So you just need to reselect the belt path for different segments, and the tool will automatically update everything for you, and you get at the end in few clicks the seat belt readapt to the new configuration. I didn't have the time to make a recording for this one. I may add one recording later as a new slide. And finally, inside the MPDB tool for the post-processing of the MPDB load case, we have introduced the physical test scan data plotting. So a customer who has done a physical test and has the possibility, for example, to scan the deformed barrier after the crash, can import this data into the tool, which then will enable the plotting of the, as you can see on the screen on this picture, the plotting of the intrusions and the calculation of the standard deviations value and so on, which are needed for the post processing of this load case. Here, for the sake of confidential data, I cannot show any recording on this process, unfortunately. But just to mention that this is available now in the tool. So that's it from my side in terms of updates for the explicit software interfaces and vehicle safety solutions.